Alright, the point of this video is to understand how to simplify a radical and how to decide whether a radical is fully simplified. So if we're starting with an entire radical like root 12 or the other examples there, root 18, root 50, root 72, the goal is to factor the radical into two other radicals so that one of them can be simplified and become an integer, and then we'll have a mixed radical. So with root 12, what you're looking for is a perfect square factor of the radicand 12. So I've got a list of perfect squares on the right-hand side just to help you out. So you're looking for factors of 4 or 9 or 16, etc. in the radicand 12. Obviously 4 is the only factor on that list in root 12, which means we can write root 12 as root 4 times root 3. And again, the point of pulling out a perfect square factor is that the square root of a perfect square is an integer. So root 4 can be replaced with 2. And we've now converted this entire radical into a mixed radical, 2 root 3. Now, if you try to factor 12 and use factors none of which are perfect squares, it's not going to help you. So for instance, you could write root 12 as root 6 times root 2. But neither root 6 nor root 2 can be simplified because neither 6 nor 2 is a perfect square. And so this really doesn't help you at all. And that's why the only factors you're looking for are perfect square factors. So let's try it again with root 18. So again, we could take out factors like 6 and 3, but neither of those are perfect squares. So if we look at our list of perfect squares on the right, clearly the only one that's a factor of 18 is 9. So we can replace root 18 with root 9 times root 2. And then we can simplify the root 9 to get 3 root 2. All right, looking at the next one, root 50. Looking down the list, 4 is not a factor, neither is 9 or 16, but 25 is a factor. So we can replace root 50 with root 25 times root 2, and root 25 becomes 5. So we get 5 root 2. Now, when we get to 72, or root 72, we face a bit of a problem, because if you look at the list, there's actually a lot of numbers there that are factors of 72. 4 is a factor of 72, 9 is a factor of 72, and so is 36. So what if you wrote root 72 is equal to root 4 times root 18, and then wrote it as 2 root 18. Somebody else might take root 72 and write it as root 9 times root 8, and get 3 root 8. And finally, somebody else might say, well, I can take out a factor of 36, and I can write this as root 36 times root 2, giving me 6 root 2. Now, who's right? Well, all three of them are equivalent expressions, but the only one that is fully simplified is 6 root 2. And the reason is both root 18 and root 8 can be further simplified. We've already seen how to simplify root 18. It becomes 3 root 2. And so this ends up becoming 2 times 3 root 2, which ends up becoming 6 root 2, exactly what we get at the bottom. And what do we do with root 8? Well, root 8, again, we look for our perfect square factors, and we see that 8 has a factor of 4. So we can replace this with root 4 times root 2, which becomes 3 times 2 root 2, or in other words, 6 root 2. So they all become 6 root 2. So when you're looking for your perfect square factors, you really want to pull out the largest perfect square factor that you can find. And so you might actually want to start from the bottom of this list and work up. Now, you don't need to obviously look for factors that are bigger than the radicand itself. So if you were looking for perfect square factors of 72, you would have to start maybe at 64. Obviously that's not a factor. 49, that's not a factor. And then when you got to 36, you would pull that out and be able to simplify this in one step.